16 labels in total are available. And then the next field is a 3-bit field which is being reserved for the experimental purpose. And the next field is a 1-bit stack field. It is for the representation of the last entry in the label. And finally, an 8 bits are being available for the time to live values. These are the contents of the chim header. Next, coming to the forward equivalent classification, as we have already seen in MPLS, the packets can be grouped or it can be classified based on a few characteristics. So those characteristics can be destination IP address, source IP address, port number, type of service, and application used. So based on any of these parameters or a combination of these parameters, the packets can be grouped and they can follow a same LSPs to reach the destination. This picture tells the forward equivalent class. Here is a good example. There are 4 IP packets available. They are coming to the ingress LER. So there the LER attaches the label L1 for the first packet. So here based on the characteristics, the assumption is the packet 1 and 2 they belong to the same group and packet 3 and 4 belong to the same group. So here they will follow packet 1 and 2 will follow a path to reach the destination. Packet 3 and 4 will follow same path to reach the destination. In this case, you can see in the picture the label numbers also remains the same for all the packets which are there in the group. So for the first group, the labels L1, L2, L3 are used, and for the second group, labels L4, L5, and L6 are used. So, what is FEC? It means grouping of packets that are treated the same way by any router, and this has a lot of advantages, which is it provides flexibility, scalability, and it helps in the traffic engineering as well. This kind of classification or prioritization, it is already there in the existing legacy routing concepts. So, but there is one difference between the existing ones and the MPLS concept, which is the MPLS, this FEC, the equivalent classification is done only at the ingress network, whereas in the legacy routing, this classification can happen at each hop. That is the difference. And some of the MPLS benefits. First, it's a traffic engineering. So the since the packet chooses the next hop at every hop, so at every hop only the next hop is chosen, not the entire path is selected. So by that way we can avoid the congestion path and we can go with the other paths. So by that way the traffic management has become very efficient. And then the VPNs. So VPNs are being utilized in the packet switching and over internet for security purposes. Whereas in MPLS concept, since the service providers they are creating some like a tunnel only they are creating, no, they have LSPs, that is label switch paths are being designed, and through that path only the packets are moving. So that's why it creates already a secured path and no need for additional encryption concepts. So that is one of the advantage of this MPLS. And the third one is layer 2 support. As we have already seen in the previous slides, this MPLS can cross, the packet can cross across any of the data link layer protocols. So for that, the new standards has been included such as PWE3 and PPVPN working groups. They all support for this particular characteristics. And the last one is elimination of multiple layers. So in the most of the carrier networks, they have an additional overlay model such as particularly SONET and SDH for layer 1, ATM for layer 2, and IP for layer 3. Whereas with MPLS, the carrier can migrate many of the functions of the layer 1 and the layer 2 protocols. And by that way, it simplifies the network management, and also it reduces some of the complex